together. Add them up. And it's used with the word or. Okay, in this next example, we have the National Center for Health Statistics. And they tell us that in December of 2008, 70% of all households have a traditional landline telephone, 80% had cell phones, and 60% had both. Let's say we randomly selected a household, and we want to make a two-way table and a Venn diagram. Now, I don't know about you guys, but I work a little bit better with pictures, so I'm going to make a Venn diagram first. When I make my Venn diagrams, the first thing that I do, since there are two events, I make my two circles, and I ask myself, is there a possibility of the two events occurring at the same time? And the answer is yes, because they told me they were both. So I overlap my two circles. In the first circle, they talked about landline, so I'm going to call that L for landline. And the second one, they talked about cell phones, so I'm going to talk about cell phones over here on the right. And then I start with, where do they overlap? So the percentage that had both was 60%, or in other words, 0.6. I put that in the overlap. And then I have to be careful because I look at how many had landlines, and 78% of all of them had landlines, but 60% are already accounted for in the overlap. So in the outside part here, which is still inside the L but outside the overlap, I put 0.18. And in the cell phone, since 80% of all households have cell phones, but 60% are already accounted for, I put 0.2. Does that total up to 100%? No. So I add all that up, 60%, 80%, 98%. I notice that there's something missing. I put that still in the sample space, but outside the circles, or in other words, 0.02. And this is of course, my whole sample space is the rectangle. So that's the picture of what's going on, or in other words, the Venn diagram. I can also make a two-way table. So from our previous picture about the two-way table, we know that we have to talk about the two events. We have the landlines, we have the cell phones, and we have our total. And then we also know that when we make our two-way table, we go both ways. So we could talk about the cell phones, or sorry, cell phones, landline, and our totals. So the reason we do it this way is because what percentage have landlines and cell phones? Well, I know that happens to be 60%, so I put a 0.6 here. This 0.6 is representing that both cell phones and landlines are 60%. And then I look for only landlines, which is the L cross L. And how many people have only landlines? That was 0.18. For a grand total of landlines of 78%. Does that make sense to you guys? Okay, so I cross them to see where they overlap, and then when I'm not overlapping, that's the part that they don't overlap, and then the total. So cell phone and cell phone was 0.2. Cell phone and landline, we already knew was 0.6, for a grand total of 0.8. And then I can just total up all of these columns if I want to, so 0.8 here, 0.78 here, and the grand total, of course, we don't really put in the corner as, that doesn't really make any sense, does it? Did I make a mistake?
No.
Okay, 10 out. My bad. Yeah, it should be yes or no. Erase that part. Erase this part. My fault. Sorry. So it should be cell phone and, I put landline, but it should be no cell phone, and landline and no landline. And then we put the percentages in. So how many people have a cell phone and no landline? Cell phone, 0.2. And then I talk about my total. I think that was messing me up. So the total there is 0.8. And then a landline but no cell phone was 0.18. and 0.78. No landline and no cell phone, 0.02. And for a grand total of 0.22. And then the 0.18 and the 0.02 was a total of 0.2. And the good news is that I knew I was doing something wrong because my total was not 1. So now I know I got it right, and I have 1 for my total. So if you're doing your two-way table, you'll know. Sorry. So now I can also find probabilities from this information, either from my picture or I can find it from my two-way table. Let's find the probability that the household has at least one of the 2 phones. We are going to use the correct symbology to do this. So you want one of the 2. So I want the probability of either having a cell phone or, which symbol? Union, landline. And so a cell phone or a landline was a total of, not 0.78, 0.98. Because there were only 2% of the people that didn't have either in the sample space. And then in the next group down here, it says find the probability that a household has a cell phone only. So the probability that you're going to have a cell phone and not a landline. Right? Because the complement of having a landline. Thank you. So in this example, in our Venn diagram, we're going to have a rectangle to represent the whole sample space. Circle A is going to be the event of being a homeowner. Circle B is going to be the event of not a homeowner. And you should label your circles with those capital letters. You don't have to use A and B. They're very commonly used letters, but you don't have to do that. You can do H for homeowner and N for not homeowner if you want to. Doesn't matter. Off to the side, make sure you tell the people who are going to be grading your exam what you're talking about. So as I look at these two things, I'm talking about oh, I see what you're saying. I put homeowner and homeowner, didn't I?
Yeah.
Okay, that's kind of dumb. So, Mara, what did you make event A?
Homeowner.
So, homeowner. What did you make event B?
Graduate.
Graduate. Okay, sorry. Now I get what you're saying. So, HHS grad. My bad. Sorry. Thank you. So, homeowner and grad. So, how many people are a homeowner and a grad? 221. So, the 221 is where they overlap. And I think, Zach, this is what you were talking about when you were asking about could the number in the middle be bigger. And so, in this case, it's going to be. So then part A are the homeowners that are not high school grads, which would be a total of, how many? 89? No? 119. Based on my information, 119. Aaron, can you stop, please? So in the circle, I want homeowners and grads. That's 221. In A, but not in the overlap, I want homeowners, but not grads. So here are the homeowners, and not a grad, 119. Based on my information about what I called A and what I called B. So I'm using Mara's labels. In B, I want anybody who was a high school grad. So here are the high school grads on the left in the table, but not a homeowner. And that would be the 89. Now, some of you, if you did it the other way, your 89 and 119 will be flipped, right? But everybody in here should have a 221 in the overlap and a 119 and an 89, depending on how you labeled your events. So for those of you who switch the events A and B, then you will have the numbers flipped. Does that make sense? And then down below in part B it says how many people in this survey are a high school grad and don't own a home. And we have to do symbol notation. So I go over here and I go, okay, I'm looking for the probability of being a high school grad. So what is that for us? B. And, so that's intersection, don't own a home. So that's A complement. And that would be a grand total of?
17.
How many?
89.
Oh. And if I wanted that out of the total was 500. Oh, we forgot something, didn't we? Yeah, what's out in the outside part? 71? Okay, thank you. So 71 people don't fit in either of those circles. And then the last part says, what about the probability, oh, they say how many people, I'm sorry. I didn't even answer the question, did I? My fault. So the answer is 89. How many people? I thought they were asking for probability. So if they're asking for how many people, the answer is 89. If they want the probability, this is how you would write it, and that's what the probability would be. Sorry about that. In part C, it says how many people again, so I'm not going to do probability this time. How many people are not a high school grad and don't own a home? And that's everything outside of our circles. So that's 71 people. So unlike me, make sure you read the question. They did not ask for probability. Don't do probability. Write down the total. The last thing is, so first of all, in the symbol notation, because I wasn't doing probability, what I'm looking for in the first one, just to be clear, is I'm looking for B intersection, not A complement. And the last one, if I'm looking for the symbology, what I want to talk about is not and not. So I say I want A complement and B complement.